gentleman asked me, he said, well, what's the most important thing about chicken nutrition? And I probably said something about amino acids or energy or, some nutritional explanation. And he said, no, the most important thing is making sure that there's feed on the farm.
Hello, everyone. Welcome to this episode of the Feed Science Podcast Show. I am one of the co-hosts, Wilmer Pacheco, and I'm joined by Dr. JT Pope. How are you, JT?
Doing well, Wilmer. Good afternoon.
Well, it's good to see you, JT. We had the opportunity to study together at NC State when we were grad students a few years ago. But for those who don't know you, could you please, share some of your professional experience?
Yeah, so like Wilmer said, my name is JT Pope. I'm a nutritionist, one of the nutritionists at House of Rayford, and we're a still family-owned company that we process about 4 million broilers a week, and kind of where I got to Rayford from is I grew up in central North Carolina, and my dad bought me an incubator one year for Christmas. So I started hatching quail eggs and had a good time doing that. So when it came time to go to college, I went to NC State because they had a poultry science program, and that's obviously where I met you, Wilmer, many years ago now. And I got interested in feed manufacturing because there was a job there at the feed mill. So I started working at the feed mill as an undergrad at NC State and spent many years there. And then I started graduate school and kind of naturally transitioned over to doing more nutrition-based research because I was constantly seeing all of these research diets and, kind of curious about why is there more methionine in this diet than the other one, while making research feeds for folks. So that's kind of how I got into nutrition research and feed manufacturing. And, it led to a job with House of Rayford, and I've been there about 5 years now. So
Evonik Animal Nutrition is committed to ensure food security and safety while reducing the ecological footprint of animal farming. Its products and services use evidence-based solutions that seek to promote animal welfare and reduce reliance on natural resources. All this is underpinned by long-standing industry partnerships and deep customer understanding. Evonik's focus on efficiency, sustainable, healthy nutrition, and collaborations with livestock farming partners creates value for customers and consumers.
Excellent. And, something that I can see, with your experience, JT, is that even before you went to the industry, right? When you were at NC State, you got that opportunity to work in feed milling and nutrition, and now you are getting more exposed to those areas as a nutritionist at House of Rayford. So maybe if you could share some thoughts on what do you think that we can do in feed manufacturing to impact positively the performance of the birds?
Yeah, so one of a nice experience that I had just on an internship with Rayford years ago is I went to a farm, and a gentleman asked me, he said, well, what's the most important thing about chicken nutrition? And I probably said something about amino acids or energy or some nutritional explanation. And he said, no, the most important thing is making sure that there's feed on the farm. And that kind of stuck with me because that's nutrition. We don't operate in a silo. We have to consider all of the factors whenever we're changing formulas and being in close contact with the feed mill to make sure that those diets are running properly, and to make sure that they're not struggling on the supply side with anything, to make sure that we just have constant availability of feed at the farms. So that's kind of one of the first ways that nutritionists have to work directly with the feed mill.
So maybe the other things that I would like to know is, what will be like the effect of, feed manufacturing on performance? Maybe like what are your thoughts on, the particle size, or, the mixing uniformity, or pellet quality?
Yeah, certainly. So we can just go through all of the processes. I mean, starting off from a nutritional standpoint, we would prefer to have a coarse grind in our birds. I know that might be different for the swine guys or for other animals, but in chicken specifically, especially if you're growing a large bird like we do, that's over 9 to 10 pound bird. There's no reason for us to have 400 or 500 micron corn there. To make sure that we get the best digestive efficiency from the animal, the gizzard has to work. So we're constantly shooting for 800 to 1,000 or even higher than that micron particle size on our corn. So from there, going to the mixability of the diets, we do a lot of mixer analysis. We're usually doing them quarterly, and luckily, from what I've seen, we haven't really ran into any issues with mixability. The only thing that I've seen kind of give us a hard time is maybe when we were using high fiber ingredients, where we weren't getting as good of uniformity, maybe because mixer fill was too great or something along those lines. But for the most part, from what we've seen, mixability is usually really good. But that probably means that, our guys in the feed mills, they've dialed in their dry mix times, their discharge sequences, their wet mix times and everything. So we just haven't seen many issues with mixability. Now, when we get to pelleting, I think that's the part where I would imagine most nutritionists get the most worried about the process. So there's a lot of things that we can do at the pellet mills that can negatively affect the nutrients that we will deliver to our birds. And I think, over the years, there's been a big push for better pellet quality. And I'm starting to think that, there's more of a balance to that than there is just saying, hey, we've got this pellet quality target and we want to hit that at the farm. It doesn't do you any good if you've destroyed all the nutrients on the way there, and someone told me in the crowd once at IPSF that chickens don't eat PDIs. And I thought, well, that's pretty good. They don't eat PDIs. So we have to make sure that we're giving them something that's palatable, but also still delivers all of the nutrients that we expected that feed to have. So we as a company, we tend to run probably lower pelleting temperatures than some folks do, just to err on the side of caution, and another word of the wise, make sure you're checking your thermocouples on the conditioner, because it's not uncommon for those to go bad, and you might be pelleting 10 degrees above or below where you think you are, just because the equipment's malfunctioning. But we probably err a little bit on the side of caution, just to make sure that we've paid a lot of money for those nutrients, and the last thing we want to do is burn all of them up in a pellet mill, whether that be your reactive lysine, your vitamins, a lot of your enzymes are heat sensitive as well. So even going into the dye, depends on what a company's goal is as far as pellet quality. But if you're running a LD12 dye or higher like they might in Europe, it's probably not going to be great for nutrient preservation along the way. So we are a little bit softer in our approach to pelleting feeds. So a little lower temperatures. LD isn't crazy. We're pelleting at throughputs that are that should be safe, and I don't expect that we have much temperature rise across the dye. Maybe 5 degrees or something like that. But that's kind of the ways that we, as a nutritionist, just walking into the feed mills that we work with, try to steer them in a way to make sure that they can still process all of the feed that they need to process, but that the birds are receiving the nutrients that we intended for them to receive.
That's really good, JT. And I have seen some complaints, not here in the U.S., but like in other countries, where they make like the pellets too hard, and then the chickens actually don't like to eat it, and then they just take it from the feeder and put it on the floor, and that's a lot of money, right? That the companies can lose there. So since you have a lot of experience with pelleting and pellet quality, how do you keep like like the balance? Do you between pellet quality and throughput? Do you typically control that? Using with the amount of fat that you put in the mixer, or what other things you do, or do you, because like I feel like changing the all the ratios in the dye sometimes is more difficult. So I don't know what would be your thoughts on that.
Yeah, so we're are actually very stable, kind of across nutrition, but also across the feed manufacturing process. So we're more likely to see variation coming from raw material quality or the weather than we are, I think, directly because of formulation. We actually don't have any post coaters in any of our facilities anymore, or excuse me, we still operate one, and that's kind of up to that's kind of used at the discretion of the mill manager. So if they want better pellet quality, then they can move some of their fat and put it downstream. But for the most part, with broilers, our added fat in our diets sometimes are just at a level where it's barely functional for manufacturing feed, anyways. So we don't have the same fat issues that people on the swine side or the turkey side might encounter, where they're trying to put 5 to 10% fat in a diet. So our diets are kind of thankfully optimized for pellet quality from the start. So that's kind of, that's one of the things that's kind of up to the mill managers. And they communicate with us really well. If they're having problems running a diet, they're going to let us know. And like I said earlier, we can't, that system has to run. We have animals to feed. So if we have to, we'll give them diets that have a little more fat in them to get them through some raw material issues. And then hopefully we can get back on normal formulas that are optimized for, for price and for performance of the animal.
That's really good, JT. But like there is something that probably doesn't happen a lot, with your company. But maybe for other feed mill people listening to this podcast, what do you think like feed mill personnel should do if they get a formula that doesn't run as it's supposed to, or if that formula has a negative effect on pellet quality? How do they should communicate with the nutritionist?
Yeah, so hopefully they would call, and actually more often than not, whenever we're making a change, the nutritionist should be able to look at that diet and say, oh, I think this is going to actually be kind of tough to run. And whenever we do that, I'm usually calling the managers, asking them if that diet is running like we think it should be, or if they need help. Have they seen their throughput really fall off because of it? So communication there is going to be key. If they have diets that aren't running well, and for example, you might have a throughput aid at a facility, we'll often tell them, hey, just, if you need a little extra throughput aid, move that in at the expense of a pound of corn or something, where it's not really going to have an effect on the nutrition, but the feed mill manager can, get the call from his operator at 2 a.m. saying these diets won't pellet. He might say, hey, we'll put 2 more pounds of this product in just to keep the mill running. And then we can have the conversation later about how to fix that into the formulations. And like I said, every company's different. So we don't have any kind of standard pellet quality that we are absolutely trying to hit. We monitor it every week, but we don't put pressures on our mills directly to hit pellet quality targets. But if we were to, and a feed mill manager is wondering what to do, there's only so many things they can play with. If they have a post coating system, maybe they move more of their fat downstream. If they don't, and they have the time in the facility, one of the quickest ways to get pellet quality is to just slow the pellet mill down. That's going to be a really easy way. And that if you have a target and you're absolutely not hitting it from a nutritionist standpoint, I would start looking towards maybe bringing in some wheat products or something with some native proteins or gluten in there, because that's just a really cheap, binder that also brings a lot of nutrient value to it as well. So I guess that's kind of the way I think that back and forth should go between the feed mill and the nutritionist.
That's really good. And we got some nutritionists that like to listen to this podcast, and maybe I don't know if you could share some feed milling technologies that they could use to improve pellet quality or animal performance.
Yeah, certainly. So, when I think about kind of where our feed mills are, there's a lot of theory out there behind technologies that could help us in feed manufacturing, but I haven't seen a ton of that actually in practice in these large facilities. But one of the things that comes to mind for us, at least in the summertime, that's when we tend to deal with the most amount of pellet quality issues as well as throughput issues. And a lot of that is just based on moisture. So in the middle of the summer, we're getting the corn moistures that are 11, 10 to 12% moisture in the corn, where 5 months ago you were running a 15% moisture corn product. So whenever all that comes through, there is just not, there's not enough temperature rise going from your mash to your conditioner to actually put enough moisture into the process to make the pelleting functional. So I think a really nice technology that might be able to help feed mills and nutritionists kind of balance that throughput and pellet quality for the 3 hottest months of the year would be with some inline equipment, maybe inline NIR on your grinding system. That way you would know exactly kind of what kind of moisture profile your grain has. And then on the pelleting side, it's, I would imagine, I'm not an engineer, so but I would imagine that we would be getting close to being able to measure moisture kind of real time through the conditioner. And so if you knew those variables, you've got a mixer down there that you can easily add water to. And, a lot of people are going to say, oh, well, you don't want to add water because you're diluting it. And, you're diluting the nutrients, but you should be able to take that right back out of the cooler. So I think that's a really easy way that we could optimize summer pelleting and maintain pellet quality is with a little bit of water. And I know people have done that in the past, but I don't think it's like really well adopted or really well accepted. But the summertime is always the most problematic for us for throughput and for pellet quality.
One thing that I was going to tell you, JT, is that I have seen some companies that they have moisture analyzers in the mixer, and then they said, this is the amount of moisture that I want in the batch leaving the mixer, and then they might decide like 12.5. And so basically, depending on the amount of moisture from the ingredients, then they apply, X amount of moisture to get to 12.5. So that might be, as you are mentioning, a good technology to make sure that the meal entering the conditioner have the same amount of moisture, and then typically we add 3.5 to 4% moisture in the conditioner. So I just wanted to share that with you, JT.
Yeah, no, that is correct. So if you looked over time, I mean, that's going to be our biggest variable with corn. If you look at the way a feed mill is working over the course of a year, probably some of the largest variations that feed mill is going to encounter is just moisture in corn. So if you can stabilize the moisture of the corn, I think you would take a lot of your throughput and your pellet quality goals and make them much more obtainable, because you're taking out the largest source of variation for their kind of day-to-day headaches. We can't put them in a bubble and make the weather perfect for them all the time, but we can do something about the moisture in the feed.
That is true. And one thing, just to expand, because I think this is a really important topic, right? Like the control of moisture in the feed mill. Do you see when during the summer, do you see lower moisture because the corn is lower, but also because you are losing more moisture in the grinding system, or is mainly because the moisture of the corn is lower in the summer?
Yeah, I don't know specifically about the grinding system. I think it would be easy to theorize that maybe we probably lose a little bit more moisture in the summer, but we see it in our raw materials coming into the facility. So when we start off harvest between 15 and 16%, and by the end of summer, guys are kind of bringing us old crop corn that's 10 to 12% moisture. So I mean, we didn't stand a chance to control it from the very beginning. If we want to optimize that process, we're going to have to make that corn moisture consistent throughout the year.
Sounds good. Yeah. And what other, technologies do you think like a nutritionist can use?
Yeah, I love the idea of inline NIR. I think I've been to one facility that has it, and it was actually a while ago. I highly doubt they're formulating with it, batching with it, all of those things that it's intended to do. But I think they're, over time, if we want to get more, if we want to be more efficient with our raw materials, I think inline NIR is going to be the way to go. I don't know how, I haven't even played with it myself. I don't know how far off we are from that being obtainable. But, when I think about people talking about, sustainability metrics and all of these types of things, one way that you can be really sustainable is by making sure that you're not over formulating for nitrogen. You're not over formulating with energy, that you're really conserving these valuable nutrients and making sure that you don't give the bird any more than it needs to be cost effective. So I would love to see inline NIR become a larger part of the industry. And I think, I don't, again, I'm not an engineer. I know very little about artificial intelligence, but I would imagine that learning curve is probably a lot quicker using artificial intelligence as opposed to just, you and I sitting in a room looking at a bunch of batch records and saying, oh, did it hit target or did it not? And so that's one of the things about, being a nutritionist is we're looking at raw material values all the time, and we have to make a decision. Do we want to stick with the diet that we're on, or do our raw materials dictate that we actually need to change our formulas? And with inline NIR, I guess you, instead of looking at values all the time, book values or what a lab is giving you, now you become kind of the overseer of this technology that's making all these decisions, and you're making sure that it's calibrated and tuned properly to dial in every single batch of feed. I don't know any nutritionist that would be comfortable with that right now, but perhaps in 10 years or maybe in 20 years, that's going to be a much more feasible technology for us to implement because it will have improved a lot by then.
That's true. And I mean, I'm sure that you have seen this too, but I mean, there are some companies that are using NIR to measure the particle size of ingredients, right? I mean, you can just use the tool in different areas of the feed mill, and like sometimes I think about the potential of NIR an NIR analyzing the particle size of a ground material, maybe corn, and then telling the BFD if it needs to move faster or slower to get to the target particle size that you want to get in that facility. So there is a lot of potential out there.
Certainly. Well, we have all of these goals that we've set, right? So you want to get this specific particle size or this specific PDI. But in all honesty, making those changes, we're often so slow to actually get to make the change that by the time we've implemented the changes, our raw materials have changed or the weather has changed. And it's no longer, the change that we made that we thought would get us to that specific particle size is no longer going to work. So having something that's real and in time would take that kind of guesswork out of it. And once it was calibrated, I would imagine it would work as a really good tool to make it so that if you want 1,000 micron corn, like you said, you hook it up to a VFD, they're talking back and forth. And I mean, and it just slows down or speeds up to kind of optimize the process.
And the nice thing about that is like it could account for like the differences on the corn, maybe entering in, and then adjust to those changes in the characteristic of the incoming material. And like since we are talking about particle size, I would like to get your thoughts on hammer mills versus roller mills, because if you go like to the southeast of the U.S., everybody who is pelleting diets use, hammer mills. But if you go like to the Midwest and people use more like mash diets, they use roller mills. What is your, thought on that?
I believe that a roller mill has it definitely has its place even in, like a broiler integrated feed operation. So, there's a ton of research out there telling us, as we talked about earlier, that a broiler needs a coarse grind to make the gizzard work and for digestive efficiency. I know you've done a lot of research on that. I've done a bit. A lot of folks we know have worked on that. So there's no question that broilers benefit from having a coarse grind. One of the things that I've noticed since working in some of these larger facilities is that achieving a coarse grind with a hammer mill is very difficult. And even if you can get, the particle size that you want with a hammer mill, oftentimes the distribution of those particles still doesn't lend itself well to having something that can flow. So like for a mash feed, for example, let's say you should have no problem getting a 1200 micron diet to flow using a roller mill. But all of a sudden you start getting 1200 micron corn with a hammer mill, that diet may not flow at all when it gets out to the farm. And in a perfect world, I guess I would have, a hammer mill and a roller mill in the same facility. Or if it's a large facility and you have 4 grinding units, maybe 3 hammer mills and 1 roller mill. Because at all times there's a need to have coarse corn in a broiler operation. So you could operate 3 hammer mills wide open and get a nice, 600 micron grind or something out of them, and then use this roller mill to give you a 1500 micron grind and just dose that coarse grind in different amounts based on the phase that the bird is growing. So I think they have a good role to play on the broiler side, but I think its most important role might be in the breeders, actually.
Okay. And why is that?
Well, I think, one of the things that I've seen with us is we tried to transition a facility over from making pelleted and crumbled breeder feed over to mash feeds. And that's what I was getting at with the particle size. We could hit, a particle size objective, or if you read the literature that, hey, this would be a good particle size for breeders, or that it should flow here. And what we would see is that we would hit that particle size objective, and then feed would get out on the farm, and the breeder guys are saying it's not flowing, and that's a huge problem for us. That is like, that really is breeder nutrition 101. If they don't have feed, you're in trouble, and you're in trouble quick. You only get to not give them feed for like a day, and the whole flock is messed up, right? So that's that. We can't live with that. We have to have feeds that flow. So I think that having a roller mill on site would allow a complex that's going to be feeding mash breeder feeds to not have to pay so much attention to grinding all the time. You set roller mills up, what particle size you're trying to hit. You make sure that it's going to reach that objective, and you just kind of let it run, because the distribution of those particles is so compact that they flow and you can feed it out well. Mm-hmm. But I think one of the kind of biggest pushes that I see coming maybe in the next 5 or 10 or 20 years is, feeding pullets has become much more difficult. And we saw some data from one of the primary genetic companies recently that said that the broiler breeders today, or the pullets specifically, are consuming their feed 50% faster than they were 10 years ago. And that's really problematic for us because, it's already difficult to feed breeders with feed distribution issues. And then when we pellet them, we're actually taking a diet that should be, it shouldn't be all that dense, and we're making it denser by pelleting it. So I think one way that we could easily add volume to our pullets is by simply stopping the pelleting process and using a roller mill, which we know the feed will flow, and we can pick up distribution, we can pick up volume for that bird, and we can get all the feed into the house. So it would be really scary to try to feed a bunch of pullets with a hammer mill because it just doesn't flow that well. But if we had a roller mill and you could get that 1400 micron corn that is going to flow and that's going to be able to keep up with the equipment, I think that's going to be really important for us moving forward. And I highly doubt the speed at which they feed will become slower over time. So, 10 years ago, maybe this wasn't a concern with breeders, but I'm worried that one day we're going to have to go back to feeding them mash feeds because they just eat way too fast.
Yeah, and another thing that I'm thinking right now, JT, is that like if there are some differences in poricle size and you are feeding mash, there might be even some segregation inside, the silos. So you want that poricle, as you mentioned, like to be as uniform as possible, not only to get good flowability, but also to reduce segregation in the silo at the farm, and that might help, with a bird uniformity, which is very important as well.
Yeah, certainly. And that's something we deal with all the time whenever we're pelleting like breeder feeds, is kind of that last bit of feed that comes through will often be a bit powdery.
Mm-hmm.
And the birds don't like it. The people on the farm don't like to see it, and it doesn't flow as well. So anything we can do to remove some of that variation in the size of what we're offering those birds, I think would be advantageous when we go to feed them.
So, I just have another question before I ask you the last question. I remember, when I was a grad student in NC State, I had a poultry nutritionist in my committee, and he always mentioned that, when you make changes in the formula, you should always go and check, how that change affects, the performance of the birds. How often do you think that you need to, you change the formula, you need to monitor the performance of the bird? How often you need to do that?
Yeah, well, our approach might be a little bit different on that. So at Rayford, we've, my boss, Dave Burnham, he's a real big believer in consistency for the birds, and obviously being with him for years now, he's also made me a believer. So we don't make very drastic changes to our nutrition or to the nutrition program hardly ever. So we've gone through a couple major revisions of it in the 5 years I've been there. But whenever we're changing formulas, we're still hitting the same specs, just our raw materials have changed. So I haven't seen like an imminent need to, every time a formula change occurs, to go out there and look at the birds. But with that being said, we spend as much time as we can in the field. So it's not like we're just sitting in an office waiting to make a change, and then when we make the change, now it's time to go out to the field and look at the birds. I'm usually getting them at least 1 day a week. I would love to be out there more, but usually 1 day a week, 1 to 3 days a week, I'm on a farm anyways. So I get to see that, and any changes we make are always in the back of my mind that we should be looking for something. But we also evaluate everything in an internal research with internal research trials. So that's where we if we're going to make major nutrient changes or changes to the diets, that's where we're going to start them off at, where we can observe them in a controlled environment and with accurate measurements. And then if we take that data, we decide to make a change or an overhaul to the nutrition program, we'll make that change. And then, yes, in that case, we will be out on the farms looking very closely at whatever specific things we've changed. Like recently or a couple of years ago, we made a pretty big change to our calcium and phosphorus levels. And right when those changes were coming through, we were making weekly observations on farms, but also necropsy in birds, looking at bone strength and all of those things to make sure that the changes that we made weren't going to have a negative impact on the animal.
Yeah. As Dr. Breck used to say, right? Listen to the chickens, right?
That's right. They don't read the manual.
Yeah. Yeah.
Eastman serves veterinarians and nutritionists in agrochemical and animal health industries by helping them select, evaluate, and implement innovative nutritional programs. Eastman works with your team to customize your gut health approach in feed and water. Eastman's approach addresses nutritional and bacterial challenges and finds new ingredient preservation and hygiene solutions. Explore ways to accelerate and innovate your programs. Contact the Animal Nutrition Team at eastman.com.
I have, my last question of the day is, you and I, we were, grad students a few years ago, and I always like to get, the opinion of our guests on what can grad students do while they are in grad school to prepare better to their professional careers.
Yeah, no, that's a good question. I think kind of several things come to mind. One would be to just try to get as much exposure as you can to the industry or whatever industry it is that you want to work in. So, if you wanted to work in academia, I would say see if you can go visit with another professor for a summer or a semester. If you want to be a production nutritionist, give one a call and see if they'll let you come hang out with them for a day or a week. And, if you wanted to work in the allied industry, lean on some of those people to see if they could, tour you around some of their facilities or let you go visit a customer with them or something like that. I think one of the biggest things that helped me coming out of NC State, working with John Brake and Adam Fahrenholtz and Charles Stark and all those guys, was having access to that feed mill. So that was huge for me because I know for lots of folks, the feed mill can be a large learning curve. You just walk into this big concrete building, you can't see anything in them, and you're wondering what's going on all over the place. So having access to a teaching facility like that was huge for me because, I spent like 8 or 9 years working there. I was pretty comfortable with feed mills when I left school. So I would say, spend as much time as you can in the feed mill while you're there. If you can get breeder experience while you're a graduate student, that would be excellent. So, I know there's not many universities out there that still keep breeders, but anything you could do to learn about breeders or go to your nearest integrator and see if you can go out with their breeder manager or one of their breeder service techs to watch breeders feed, to understand kind of, where your mind should be as a graduate student thinking about nutrition and breeders. I mean, they only feed for like an hour every day. It happens early in the morning, but that's like the most exciting thing on a breeder farm. So see if somebody will take you to go watch breeders feed. And I would also encourage graduate students to do their own feed formulation. So, that's one of the things that they made us do, like first day in school, probably sat down with you or with some other kind of senior graduate student, and you guys would teach us how to use feed formulation programs. And we were kind of expected to start formulating our own research diets immediately. So, I've talked to lots of students that haven't formulated their own feeds before. And even if your professor isn't comfortable using whatever diets you formulated, you at least should go through the practice of it, because it doesn't matter if you're going to be a production nutritionist or you're going to work in allied industry or academia. You're going to need to understand those programs and understand enough about them to at least formulate a basic diet to do research or to understand your customers' issues. Or if you're in production nutrition, obviously you're going to need to be able to do it for to send your formulas to the feed mill every week. So I think those would be the kind of 3 main things: to spend as much time as you can in the feed mill, get as much breeder experience as you can, and then formulate your own diets.
Yeah, and something that we are doing right now at Auburn, and it's working out really well, JT, is allowing or just encouraging grad students to do internships during the summer, maybe for like a month or 2 months, depending on their interest. And I think that's going to be good for them once they are going to be more prepared once that they leave, the university and they go and work with, in academia or in the industry.
No, I think that's a great point, Wilmer. I mean, we get to see it some on the veterinary side. The veterinarians, whenever they're going through their, avian medicine program or their residencies, they pretty much have to go spend time with a commercial veterinarian or a production vet to learn about that side of the business. And I'm hoping that over time, kind of the nutrition world will become more open like that, because it's really hard to get the experience as a graduate student, but if these people are put in a position where they can go have internships, I think it can be very, mind opening to see kind of what the silo that you see at the university gets expanded out to in this very large system. And I think it could help guide their research a lot too, to help them understand the problems and kind of the practical side of why it is that they're doing trials at the university.
That's true. Well, JT, I just want to thank you for your time. I'm sure, like everybody who listens to this podcast is going to learn a lot. And I hope you have a good day.